Alright guys, here I am. So the main goal of this video is just for me to recap what I've learned so far. Okay, this is not a tutorial, so to say. So I'm seeing the learning process. Everybody's seeing the learning process, but I just have to make this video just to like outline or see what I've discovered and outline what I've learned so far. So okay, so what I have is I have the branches. Okay, so this is the main branch, which what you have here is just a plain old camera. By the way, this video is basically about camera, so you can see this just rotating around, and yeah, it's cool. The camera just rotating around. Then we have, and I have another one, which is where I implemented the camera movement based on LearnOpenGL website. Okay, so I'll basically be using LearnOpenGL website. I go to the channel website as well, just to like maybe pick one or two things, you know. So, but what I'm talking about now is that here now you can see the difference in the camera. So you can use the WS to move up and down, A and D to move side and left. Then by moving your mouse, you can rotate left to right, go up and down. Okay, so that's the implementation of the camera class, which is what we have here. All I'm just trying to do now here is to see if I can like recap what I learned from this camera. Basically, see if I can write the camera class again. So I have a new branch here, which is just an empty, is a camera class, an empty class, so to say, header file. So if you render it out, you definitely get errors, blah 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 blah. So I want to just re-implement this. So the first thing is the camera movement struct. Yeah, sorry, enum camera movement. So basically, this handles the the direction of our mouse, no, of our keyboard. Yes, keyboard. Backward. We have left, and we have right. Yep. So that's good. I'm done. Of course, not done. So the next one is the different frames initiation files values float. For we have the yaw, which is minus 90.0 f. Then we have the pitch, okay, which is 0, I think. Yes, 0 f. We have the speed, it's 2.5 f. We have the sensitivity, which is I think 0.1 f. Yes, we have we have zoom, which is 45.05 degrees. So I think that's about it. I'm not sure if that the zoom is minus, but I think let's just go with this for now. Now we'll go to our camera class camera. Okay, let's start with the private values. So we have a lot of GLM vector 3. Okay, so we have I'll start with the position, member position vector, member up vector, member world up vector, member front, member right. I think that sums up about the GLM member functions. Then we now have all these guys here that are also part of member functions. So we have I'll just do const float, not const, float myaw, mpage, movement speed, still same thing, not the speed, mouse sensitivity, vt, and zoom. All right. Okay, so now let's move on to camera class. Camera. No, I'll just camera constructor. Sorry. So I'll just photo write out all the functions so that we know what we're dealing with. So we have void okay, get get view matrix, this return glm void, glm, not glm void, sorry, glm mat4, And okay, what's data? Let me just write the parameters for this camera too. So we have word up, that's in GLM factory. Factory, that's a position first. Let me start position. GLM factory, we have up. Okay, okay, and all these guys will be initialized. Let me just go ahead and do. No, I'll come later. Then we have our float yaw and float pitch. So these are like the base. I'll come back and initialize this guy when I'm coming back to define each of them. So now next one we have is voice process keyboard. Okay, process keyboard. That takes in, let me see, yeah, camera movement. That would declare there. I can just say direction. Then takes in the delta. So delta is basically the change in time, loop cycle. So basically what we have here, delta is what we have here, the change in time by every run cycle. Okay, now the next thing we're gonna do, let me go and write the next one, is void process mouse movement. Yep. And what does that take in? Mouse movement. Yeah. So taking float x offset and float y offset. Okay, I think that is all it takes. Yes, that's what it takes. And next one we're gonna have is process mouse scroll, and all it takes is y offset. So I'm not sure if it's the same offset as this, but that's what it takes. Save this. Okay, yeah. Finally, we have void updates. Yeah, update vector updates cam vector, right? And takes nothing. And by the way, all these are supposed to be public. Okay, I think that's settled it. We have all our beautiful classes that we need. Let's now start creating their definition in here. So let's start. Let me start by first setting up default value for all this GLM factory 0.0 and 0.0 and 0.0 f. I'm sure this should even work together. Yeah, it should, but let me just do this. Let's go like this. Then for our word up, just copy and paste. What our word up is y axis. Then our yaw, set it to set our yaw to the yaw value, and does it work? No, doesn't work. It's equals to yaw, and pitch is equals to pitch. Okay, and let's go ahead and set our default value for m front is glm vex 0 -1. So basically what this does is assuming the camera is not located at the center 000. So when you go to like the main view, you see our first position of the camera. See here, I think it's under renderer. Let me go to renderer. Yeah, under renderer, you can see the position of the camera is 3. So it's basically moving forward from the position of the camera, from the center of the camera. We are assuming all our objects at the center. So if this is the center, the camera is going forward. So if we are going to read what is here, we have to like count in a negative. Hope that makes sense. Well, I'm sure it makes sense if you read the book, but again, this is not like a tutorial. I'm just trying to recount what I learned so far, and let's move on. Okay, so m front. What else again? Am I missing? M. Oh yeah, m your m pitch, m movement speed. So movement speed, shift to movement. okay, speed. Speed. Mouse sensitivity. Change it to sensitivity. And finally, zoom. Assign zoom value. And so let's just implement the camera. So what we just have to do is our position, position become pose, up, no, word up, so that like our false default value comes up, which is what we set there. Which other one do we need to set? I'm not sending front now, neither are we sending the up here. All these other ones, all front and right, will be set right inside the update cam vector. So all I have to just call now is the update cam vector, and our camera class has been implemented. So we have our vector, update cam vector here. Okay, so the next thing I'm going to implement is get view matrix. So if you do return glm look at matrix, so we have first thing is our end position of our camera, then the target position, which is our camera position, plus the object in front, that is at our center in front. Then we have our camera up, so just do up, m up. Okay, so I think that one is good. The next phase we want to do is this our camera, our keyboard press, which is so the first thing we know, we need to create a variable called velocity. So all of that one takes in the mouse speed, yes, times delta time. So that what gives us the velocity. So then we do if direction is equals to forward, uh, our position camera, our camera position becomes m forward, right, m forward times the velocity, So basically, why is this one showing like this? Oh, sorry, I'm doing m front. Okay, so this is supposed to be forward, not front. So I'm going to change that. F2 forward, not front. So okay, I think, yep, all good. Right? No, sorry, it's supposed to be front. My bad. Front times velocity. So we're just going to duplicate this a couple of times. 1, 2, 3. Now, so we have if direction is equals to backward, we have in position is equals to m front minus velocity. Then if direction is equals to left, then we have in position will become to minus, instead of m front we are going to use right now. Then if it's equals to this position is equals to right, we do m position is equals to m right times velocity. So this is basic information for keyboard press, nothing else. I think, yeah, that's it for keyboard press. Now let's move to mouse movement. So the first thing we need there is for each of our offset, we do multiplication with the mouse sensitivity, mouse sensitivity. Okay, same thing for white. Then each of these will go to our yaw as offset, and oh yeah, m yaw, then m pitch plus y offset. Right, then the next thing here is okay, there's supposed to be a constraint, so that our pitch, yes, our pitch will not flip over. So we have is constraint. Let me do bool is constraint pitch. I think let me just wait that constraint pitch is equals to true by default. So we do if is constraint, we say if m pitch is greater than 80.0 f, that's just about to tip over 90. We just set our PM pitch to 89.0 f. So duplicate, So if m pitch is less than minus 89.0f, we change it to minus 89. So then last thing we update our vector cam. Okay, then finally we have our m scroll mouse. So what this one just need is our m zoom is minus plus, if I'm right, not sure, float, y offset. Then there is a guard for m zoom 2. If m zoom is less than 1.0f, set m zoom to 1.0f. Then if justificate m zoom is greater than 45, we set m zoom to 45. Alright, so finally we are going to implement our update cam vector. So the first thing we need to do here is create a front member variable, a front local variable, yeah. So 3 front. Now this our front, we have front dot x is cosine of GLM gradients of your MUR times cosine of GLM gradients of our M pitch. So what does that gives us? This is what it gives us. So front dot y is sine, just sine, pure sine. Okay, sine GLM gradients of our pitch. Yes, I think, yeah, M pitch. Yes, same pitch. And finally, front dot z is sine. So you know what? I'm just going to copy this guy. I put it here. Basically, you'll see that changes this guy sine. Now, before we put in our front, M front, we normalize it. GLM normalize and no, yeah, front, and we're good. So our front is set. So this front that we didn't initialize there, this is like the first time that this update that we call here, this is what first initialization of our front. So the next one we want to initialize is our upright. No, right, yes, remember right. Now right is a, when we do a cross product of our word product, when time you do a cross product, if the int gives you a perpendicular vector to the two product that you are crossing, or like dot product that is like in between, a perpendicular, so that's opposite. So basically, if your word is pointing up and your front is pointing front, of course. So imagine you have a front and you have up. So the perpendicular vector to those two will be our right. So what I'm doing is GLM normalize. I have to normalize it first of GLM cross of M front and word up, M word up. Okay, so we have our right here. And finally our up, M up. So M up is the cross between our right and our front. Yes, no, right and, yeah, right and front. Yes, M GLM normalize GLM cross of M right. Yes, right comes first, then M front, and good. And this should mark the end of all the different, the class system, the camera system. So let me just make sure I have the name properly set. There's no error. When do I, let me see, in the window, no problem. Okay, so fingers crossed. Let's see what happens. Any error? Okay, I think I have the same error I had initially. Is okay, let me close. Let me go and check. So it runs perfectly well. The only thing is probably the angle I set. I think this zoom is minus, right? Minus. Am I right? Nope, it's not the cos. Am I missing here? I'm gonna pause and just check. Okay, so I think I figured out what was the issue the last minute. So I didn't initialize my yaw and pitch. So yaw is equals to your and m pitch is equals to pitch. So I believe we should solve it. Does everything that they add initially? Yeah, and it does. Okay, thank you so much.